This is the third video on state space methods linked to files in the Control101 toolbox. It's well known that state space methods are powerful tools for the analysis and design of system behaviors and control, and consequently it makes sense for the Control101 toolbox to have a dedicated section on state space models, such as those you can see here in the middle of the screen for continuous time and discrete. This particular video focuses on how system behavior is related to these models. So a reminder then how to access the files. Type Control101 in the workspace and that will open this fast interface. Go to the State Space Methods tab, and the particular files that we'll be looking at in this video are the ones with circles around them. So open loop behavior state space, that focuses on how to infer and explore open loop behavior of state space models. You'll see phase plane behavior file, a stability eigenvalues file, and a stability analysis file. Specifically though, it's going to be more effective to do a live demonstration rather than trying to describe these files just with words and text. So here's the first file then. Let's look at this one, open loop behavior. So if you open this file, and we'll give you a quick view of what's in the file. So as with most of the files in the State Space Toolbox, there's quite a lot of formal lecture type material or textbook type material you can see here to introduce what's going on before you move to the MATLAB sections underneath. So a bit of basics on the role of eigenvalues, some basics on how you calculate and plot step responses. Okay, you'll see the whole of section 3 is on step responses. So unforced responses is basically free response, if you like, a non-zero initial condition but a zero input. So there's a number of bits of MATLAB code and examples showing how you can plot those. Forced response, you basically assume zero initial condition and change the input. So again, you can see a number of different examples. And a general response, you have a non-zero input and a non-zero initial condition. So that file basically steps through how to do MATLAB, use MATLAB to create all these responses. So next file that you might be interested in could be phase plane. So what phase plane does is it looks at the states individually rather than just the output. And so again, you'll see this file starts with a bit of explanation. What is the phase space? Where does it come from? And you'll see the key role of the eigenvalue eigenvector decomposition in this background here. And once you've understood the role of the eigenvalue eigenvector decomposition, then we move to the phase plane, where essentially you look at the behavior in specific eigenvalue directions. And that's what you'll see with these plots here, where the dotted lines are the eigenvectors, and you can see how the response basically differs in each eigenvector direction. So you have a different mode in each eigenvector direction. So the file basically goes through that and has a few plots that you can look at to try and understand what phase plane behavior means. And of course, as ever, you can always change the example using the code up here if you want to look at different numbers. It also looks briefly at complex poles, and there you can see the phase plane behaviors down the bottom. Now, more generally, if you want to think about eigenvalues and the impact of eigenvalues, the next file, this one, Stability Analysis of Dynamical Systems, really is a lot more like a textbook. So you'll see it's got a lot of textbook type material going through the background of the influence of eigenvalues on the behavior of a state space system and eigenvectors as well. So you can see a lot of material here basically going through the background. And then later on, once you've got through that, there's a bit more basically discussion of general behaviors. So you'll see this file is really a lot more like a textbook with just small snippets of MATLAB here and there to illustrate the concepts. So this file I would recommend for people really trying to get to grips with some of the fine details of the behaviours of state space systems, the roles of the eigenvalues and so forth. But the people who are really more interested in the details. And in a similar way, if you look at the stability analysis file, you'll find it's equally detailed in terms of the level of information that's provided on how systems behave. And you might think this is slightly beyond your needs, but as ever, it provides bits of MATLAB code to illustrate key concepts, which therefore you may find quite useful. And you can see the production of all of these useful figures demonstrating behaviors that you might want to look at. In summary then, this short video has given a quick review of the introductory resources to support the study of state space system behavior, and as ever you can access the files by clicking the relevant buttons in the Control101 toolbox interface. Here we focused on producing time responses in both the output space and the phase space, as well as understanding the core roles of eigenvalues and eigenvectors in the behavior. Now it's implicit the core concepts in these files will also apply to discrete systems, even where they may not have been discussed explicitly.